Section 6.3 notes. This is on the back of the notes for Section 6.3. Follow along for Part B and Part C.
All right, the second major topic. Our first one was classifying. Our second one is actually approximating square roots. So if it's not a perfect square, can I approximate what the answer would be? So our first problem is going to be estimate the radical of 52 to the nearest integer. Now, understanding vocabulary is huge. So integer are positive whole numbers and their opposites. So there's no fractions in here, no decimals in here. We're just looking at whole numbers and their opposites as our final answer. So use the number line. So I just drew a blank number line for you to use to place the square roots of the perfect squares that we should know to the nearest radicand. Then we're going to place that 52 between there. So what is 52 close to? So we have the radical of 52. We know that 52 is not a perfect square, but what two perfect squares is it between? And a little bit less than 52 is 49. And the radical of 49 is a perfect square. And the one above that, if you remember correctly, would be the radical of 64. So the radical of 52 is somewhere between the radical of 49 and the radical of 64. So I'm going to place the radical of 49 right down here. I'm going to place the radical of 64 right about there. But what is the radical of 49? So I'm approximating that the radical of 49, am I really approximating? No. I know it's 7 because 7 times 7 is 49, so the radical of 49 is 7. Same thing with the radical of 64. I get 8 as the radical of 64. So where does 52 fall in? Is it closer to the radical of 49 or is it closer to the radical of 64? Hopefully you can see 49 and 52 are 3 units away from each other, and the radical of 52 and the radical of 64 are 12 units away. So it's obviously a little bit closer to the radical of 49. So I'm going to place it right about here. I'm going to call that the radical of 52. So to fill in our notes at the top, it says the nearest perfect square less than 52 is 49. And that's what gives me the left boundary marker, that I know that that's below it. That's the minimum. And then we have the nearest perfect square greater than 52, which I just went through, is 64. That's going to be my maximum. I know that the radical of 52 has to be somewhere between the radical of 49 and the radical of 64. And I use my number line to approximate that. So to estimate the radical of 52 to the nearest integer, by sight on my number line, the radical of 52 is approximately 7. I know it's a little bit more than the radical of 49, so my answer would be the radical of 52. Now remember, it's an approximation, so we have to squiggle the equals. We're saying it's kind of equal to, it's approximately equal to, and we can say 7. And remember, we're picking integers, so we don't have to worry about any decimals after that. So now I want you to do the checkpoint. Again, I'm going to give you a couple seconds to pause this, but you're going to want to pause this because it's going to go straight into the next video if you don't. So you have 4 problems. You're going to estimate using the nearest integer. Now remember, you have to put what's the minimum, what's the next lower perfect square, what's the next higher perfect square, and try to figure out that new radical that you're estimating. Where does it fit in? Is it closer to this number or is it closer to this number? You're going to do the radical of 33. You're going to do the radical of 85 for number 2. Number 3, you're going to do the radical of 190. And for number 4, you're going to do the negative radical of 7. Because remember, integers are both whole numbers, positive whole numbers, and their opposites. So we have to worry about those negative roots as well. So number 4, you'll be working on the negative part of the number line. And make sure you remember how we set up negative number lines. So try that. I'm going to give you a couple seconds to make sure you can pause, and then we'll talk about it tomorrow if you have any questions. All right, so just like in math, if I can classify it, put it in rational or irrational form and to know which it is, the second thing we have to approximate it. Well, the third thing is to compare it. So if we know how to approximate something, can I compare it to a different number? And that's what the third section is about, Part C, comparing real numbers. So we're asked a question, which one's greater? Is the radical of 5 greater than 2 3/4, or is 2 3/4 greater than the radical of 5? Which one's bigger? So we're going to make a plan. Our plan is to use a number line so that we can approximate that in a number line, and we can see which one is greater by living to the right. Numbers that are to the right on a number line are greater than numbers that are on the left. So that's our plan. We're going to do a little workout to figure out where those things fall in on the number line, and then we're going to make sure that we answer the question, is a radical of 5 greater or less than 2 3/4? So a little work that we have to do. So we're going to do radical of 5. And remembering correctly from video B about approximating, we have to figure out where does the radical of 5 fit in on the number line. We have to find a perfect square less than that as our minimum, and we need to find a perfect square that's greater than as our maximum. So 5 is between the perfect square of 4 and the perfect square of 9. So we know that it falls in between there. The radical of 4 is 2, and the radical of 9 is 3. So I know that the radical of 5 is going to be 2 point somewhere in there. I just don't know where. So 4 to 5, this unit is only 1 unit apart. But 5 to 9 is 4 units apart. So I know it's a little bit closer to the radical of 4. So that's how I'm going to set up my number line. So the number to the left is the minimum one. So I'm going to say that's the radical of 4. And again, I'm going to give myself space so that you can have a little room to work. And then my maximum right here is the radical of 9. Remembering that the radical of 4 is 2 and the radical of 9 is 3. I need to place that. Well, it's only really 1 unit. And between 4 and 9, I have 5 units. So if I break this up into fifths, this is radical of 5, radical of 6, 7, 8, radical of 9. Do you see how I count? So instead of counting by numbers, we can count by radicals. Radical of 4, radical of 5, radical of 6, radical 7, radical 8, radical 9. So where does 5 fall in? It falls in right here. So it's closer to the 2, just like I approximated here from the distance. Now, where does 2 3/4 live? Well, 2 3/4 is in mixed form. We could change it improper if we wanted to, but since we're relating this in decimals, I'm sure you know how to figure out the decimal equivalent. So 3/4 is the same as 75/100. So we can say that's the same as 2 75/100, also known as 2.75. So 2.75, is that going to be closer to 2 or is that going to be closer to 3? And if I grab a different pen here and I use a different way to mark this, so instead of marking this in blue, counting by radicals, what if I looked at it in red by numbers? So if 2 is where the radical of 4 lines up, and 3 is where the radical of 9 lines up, where does 2 75/100 live? Well, you know that between 2 and 3, halfway, right about there, we'll just say, is 2.5. And then halfway between 2 and 2.5 is 2.25, or 2 25/100. So that means halfway here is 2.75. So instead of breaking it up according to radicals, I broke it up according to decimals. And now I'm going to say approximately 2.75 is located somewhere in this area. Don't know exactly where because it's just an approximation, but I know it's somewhere over here is 2 3/4. Well, that's actually closer to the radical of 9 than the radical of 5 is. So when you look at this and knowing that as we move right it gets greater on the number line, we can see that since 2 3/4 is to the right of radical 5, that 2 3/4 is greater than the radical of 5. And that's what my conclusion in sentence form is going to be. That the 2 3/4 is greater than the radical 5. And we could have just used the symbol too. We have a symbol means is greater than. So if you don't want to write it in a sentence, we can also use it as symbols. So 2 3/4 is greater than the radical of 5. So now I want you to try this process on your own. So you are going to disseminate which one's greater in this case. You have the radical of 36/100 or 0.6 repeating. So now you're going to have to fill out your number line, approximate that radical first. Where does that radical fall? Is it a perfect square? Is it not? So those are the questions you're going to have to ask. And where does that repeating decimal approximately fit on a number line? Then you're going to be able to do, by sight, which one is greater than the other one.
This is the final Part C checkpoint. Please pause the video and make sure you copy this down, use the number line, and we'll talk about it tomorrow.